Okay, so welcome back. We got another video here, and today we're going to be talking about, actually all this week, we're going to be talking about stuff you're going to see a lot of next year. And a lot of next year we'll be dealing with things called polynomials. So it's a big long word, but if we break it down into kind of two words there, it's easy to remember what this means. So when we see poly, like when we see polygon, remember that was a multi-sided shape. So what the word poly actually means, we can think of it as many. Okay, so we got many. What the second part of our word means, the nomials part, for our cases we can think of that as terms. So what we've got here, what this is we've got many terms. And so remember what a term is it's just parts of our equations or expressions that are split up by a plus or an addition sign or a subtraction sign, so a plus or minus sign. And you'll see more about those here in a second, but that's the definition of polynomial. Let's move on and do some example problems. So here, the first thing we're going to be doing with this stuff is we're just going to be simplifying these polynomials. And what they mean when they say simplify, or what I mean when I say simplifying polynomials, is basically we're just going to combine like terms. Anything with the same variable, and same exponent we're going to combine. So same variable, we're running out of room over there. Same variable and same exponent. Anything with those two things we're going to combine into one. We're going to add them together. And basically what we're going to be doing, if we have a variable, we're going to add its coefficient. Okay, so for example, we've got to remember what a coefficient is. That's just the number that's attached to our variable. And when we don't have a number attached to our variable, we can think of it as a 1. Okay? So again, to simplify this, we're going to combine our like terms. First off, I just like to start with the first one. It's the easiest. Let's combine anything that has an x. So for example, this 1x, or just plain old x, we're going to combine the x and the 3x. 1 plus 3 would give us 4x. Okay? We would do the same thing. Now we're going to go on to the 5. If there are any other constants or just plain old numbers sitting out there by themselves, we would add them together. Since there are not any other constants, we're just going to rewrite it. It's going to drop down. And then we look, we've already combined this, so we don't need to deal with it. We look at our x squared. Again, there's no other x squareds that we can combine it with in our expression here, so we just rewrite it. Okay? Now we've done the problem, we've simplified it, but one thing that us math teachers are pretty picky about is we want this in standard form. So what standard form is you start with the highest power of your variable, and that always goes first. So we would rewrite this as x squared. Our next highest power of our variable is just x, so it's plus 4x. And then we don't have any other variables. It's just the 5. So this would be what we're looking for. This would be our correct answer. That's 100% right there. Remember to write it in standard form. Okay, that's just highest power of x. Has to go first. Okay? So that's simplifying polynomials. We might also be adding or subtracting polynomials, which we'll get to here on the next slide. Okay, so again, adding or subtracting polynomials will pop up our problem here. And so what we're going to do is we're basically just going to be adding, in this problem, we're going to be adding anything with the same exponent and same variable. Okay? So on this one, again, what I like to do with this is I'm going to rewrite my second polynomial here because again we have two polynomials, we kind of split it up with our parentheses. I'm going to rewrite my second polynomial right under my first one, but when I do that I want to line up the like terms. So again, we see anything here with an x is going to line up with anything here with just an x. We don't have an x squared here to combine with our x squared, so again we're good there. And so what I'm going to do is I'm going to be adding this, and so when I'm adding it, I just put its sign, its coefficient, and its variable right below it. So basically I'm just bringing this down, I'm bringing this one down just like it looks. So I just brought this right down below it, and now I can add these up pretty easily, just like any other problem. I have nothing to add with my 3x squareds, so that just drops down. Be careful here, keep your negatives aligned. So we've got a negative 4x minus 2, so we're at negative 4. We're going more negative, so that would turn into a negative 6x. 3 plus 2, that one's pretty easy. That's 5. And again, this was nice because this started out in standard form. Now we've got it in standard form again. Okay? That's adding polynomials. That's not too bad. As long as you remember some of those tricks that get us when we're dealing with negative numbers. Okay, the last type of problem would be we're going to be subtracting polynomials as well. So this one gets a little bit more tricky. So this is our last problem. We're going to do this problem quickly, but hopefully we can get it. So when we're subtracting polynomials, the tough part about it is anything in these parentheses, in our second polynomial here, we're subtracting it from the first polynomial. So everything in these parentheses is being subtracted. So what I like to do right off the bat, just like when we do normal subtraction, the trick is you keep and then you change. So you keep the first polynomial just like it is. We're going to change the sign in between, so we're going to change it to addition. But if we change that sign, we kind of have to distribute the sign change to everything in there. So I'm going to make this a negative, I'm going to make this a negative, and I'm going to make this a negative. Okay, so you have to distribute the sign change to each one of them. Okay, or you can think of it, you're distributing the subtraction to each one of them. But since the way I like to think of it, we change the sign here, that means everything in there has to get its sign changed. Now we're going to do the same thing. We're going to take our second polynomial and we're going to place it right under the first polynomial, lining up any like terms. So this time we do have an x squared, so I'm going to line that up right under the x squared. We have a negative 4x, so I'm going to line that up right under the 3x. And same thing with the negative 3. And so I'm adding all this stuff, and now it's pretty easy to see it. It's all lined up, so now we can subtract or add it. So when we have an x squared, remember that's like 1x squared. This is like negative 1x squared. 1 minus 1 gives us 0, right? So we don't really need that. We don't need to write that down, just showing you here. Those kind of cancel each other out. Okay, that's nice. Second one, our second term here, we got a negative 3 minus 4. We're at a negative, we're going more negative, so that's going to give us a more negative number, which is negative 7. Negative 3 minus 4 is negative 7. Finally, we got negative 5 minus 3. Again, we're negative, we're going more negative, gives us 8. So I'm just rewriting it here. There's our answer. It's in standard form because we're going from the highest power down, which there isn't a variable here, so that works out. There's standard form answer, and there's how we add, subtract, and simplify polynomials. We'll be doing a lot of these in class, so hope you enjoyed the video. See you in class.